Hello everyone, welcome to our third episode of PFF Genome Fit. Today, I'm going to talk about how genes impact your metabolism and resting metabolic rate. Metabolism describes the way our body controls intake, storage, and utilization of nutrients. Our body's metabolism is an intricate system that involves stomach, brain, heart, pancreas, kidney, brown fat, white fat and many more tissue types. We feel hungry for a lot of reasons, like when our body detects lack of readily available nutrients. We need energy to power our brain, heart, skin and every other tissue in our body, and we get that energy from the food we eat. However, it is not efficient to eat only when we need energy. Our body has to extract extra important nutrients from the food we eat, transport them to different parts of the body and store, or discard additional nutrients which are left. To sum up, metabolism involves multiple bodily processes. Our body has to recognize when it needs nutrients, create that feeling of hunger, food-seeking behavior, food digestion, nutrient distribution, nutrition storage, halt of food-seeking behavior, use of stored material and disposal of excess materials. In essence, metabolism is hardwired to our DNA. You may find two people having the same diet, however one gains weight more than the other. This is usually the result of two factors, genetics and gene-environment interaction. Genes are you, environment is everything else: gut health, food, eating habits, hormones, toxin exposure, inflammation level, microbiome, fitness and your stress levels. After you reach the age of 40, multiple factors slow down your metabolism. The control system for hormones become unstable, cortisol level goes up, testosterone goes down and so does muscle mass. Low muscle mass means low resting metabolic rate and slower calorie burn, meaning you are potentially at high risk of gaining weight. You lose fast twitch muscle fiber first. As you age, you become less sensitive to insulin, which spikes your blood sugar level. Besides, thyroid function may also be impacted with age. All these factors lead to slower metabolism. If you feel that you are not losing weight despite following a diet and workout plan, genetics may be playing a role. It is important to note that through gene-environment interaction, genes are switched on and off based on your lifestyle cues. If you're struggling with weight gain or weight loss resistance, you should know about genes that may be driving your hunger, or making you addicted to carbs, so that you can do something about how those genes are being expressed. Let us discuss in detail about main genes that impact metabolism and weight. The first gene is for food intake, or FTO, which is associated with fat mass and obesity. FTO acts as a nutrient sensor, affecting the amount of food a person wants to eat. Variations in the gene that encode for FTO can impact the ability of FTO to regulate food intake and hunger. People with certain variations in their genes have higher BMI. However, it does not mean that people having this gene would have slow metabolism in early age and become obese. Given that these folks have low-carb, low-fat diet and indulge in regular workout and laborious work, they are less likely to be obese than those who don't. Let us talk about gene related to fat metabolism, also known as PPARG. Another gene that impacts metabolism and weight gain is the one that decodes for PPARG, a protein involved in fat metabolism. PPARG creates fat cells and helps with uptake of dietary fats from the blood. Too much activation of PPARG can lead to weight gain and increases risk of heart disease, diabetes and stroke. Obese individuals have high amount of this protein in fat tissue. I'm now going to cover melanocortin 4 receptor, or MC4R. This sits at the intersection of various metabolic processes, and helps control how much energy we consume and use, and has an overall contribution to our feeling for hunger. Some people inherit a rare version of MC4R, and these people are found to be slightly less overweight than those without it. People with genetic mutations in MC4R tend to gain weight from early childhood. MC4R deficient people have an increase in lean mass, and increased linear growth in childhood. Let us cover genes related to fat breakdown, known as ADRB2. This plays an important role in breakdown of fat. Certain variations are linked with increased risk of metabolic syndrome in women. Prevalence of this syndrome is more among middle-aged women than middle-aged men. This is another gene that can help understand the relationship between genetics and weight gain. Let us talk about gene related to stress, also known as FKBP5. This gene can make you more exposed to stress and age you quicker. This commands your body's stress response system and contributes to slowing down of metabolism. There are a couple of ways you could change the environment for your genes and metabolism. That includes external exposure and its internal impact on our body. Your genes produce specific biomarkers that can be detected in your blood, urine, and hair that indicate the effect of exposure and susceptibility factors. Now I'm going to talk about resting metabolic rate, also known as RMR. Boosting metabolism is related to transforming your body from fat to fit. This is essentially the result of increased calorie expenditure, increased lean body mass, high fat utilization, and overall weight loss. Our resting metabolic rate or resting energy expenditure plays a major role in this. Before we go into specifics of RMR, let us discuss total daily energy expenditure, TDEE. Most researchers refer to metabolism as bodily functions and processes carried out to maintain life. However, most of us refer to it as total energy expenditure and how it influences our energy in and energy out equation. TDEE consists of thermic effect of physical activity, resting metabolic rate, RMR, and thermic effect of food, TEF. Thermic effect of physical activity, or activity-induced energy expenditure. Energy expended during workout or exercise, and non-exercise activity thermogenesis, NEAT, which accounts for 15% to 30% of TDEE. Resting metabolic rate, RMR, or resting energy expenditure refers to energy expended or required to keep your body functioning at rest, which accounts for 65% to 75% of TDEE. Thermic effect of food, TEF, or food-induced energy expenditure is the energy expended on chewing, swallowing, digesting, absorbing and storing food, which accounts for 10% of TDEE. Resting metabolic rate is the number of calories burnt when your body is at rest. RMR supports breathing, circulating blood, organ functions, and neurological functions. RMR is proportional to lean body mass. With 1% increase in body fat, RMR decreases by 0.01 kilocalorie per minute. Let us now discuss about RMR uncontrollable and controllable factors. The uncontrollable factors include age and genetics. Age-related reduction in the RMR can be decreased by 2% per decade after the growth is attained. Considering RMR contributing to 60% to 75% of TDEE, it translates to 25 to 30 calories per day for an average adult. Genes also play a significant role. There are over 100 genes that are related to obesity. FTO gene causes people to overeat due to low satiety. Eating behavior with low satiety includes eating larger portions, eating calorie-dense foods high in fat and sugar, and snacking frequently. The FTO gene can alter RMR by around 160 calories a day, that is equivalent to 7.5 kilograms per year. These were the uncontrollable factors. Now I'm sharing controllable factors that include lean body mass, sleep, low calorie intake and stimulants. Building lean body mass is an effective way to boost RMR. Peak muscle mass usually happens in folks in the age band of 28 to 32, after which, muscle loss starts. Ability to preserve muscle mass and build muscle mass can prevent our age-related losses. Even a small gain of 2 to 4 pounds can boost metabolism by 8%. This can essentially add 90 to 100 kilocalorie of TDEE per day. Sleep is also an important controllable factor. Lack of sleep can negatively impact your RMR. Low calorie intake can suppress metabolism by as high as 20%. If under stress, Elevated levels of cortisol suppress thyroid-stimulating hormones production, which ultimately impacts thyroid hormones that regulate metabolism. Such low-calorie intake can also reduce muscle mass, which further decreases your RMR. Coming to stimulants, caffeine has temporary 4% to 5% metabolism-boosting impact that can impact 15 to 20 calories per day. Overall, your metabolism plays a major role in regulating body functions. But, as you can see, genes play a major impact. A proper genomics-based fitness plan will help you boost your metabolism. In case you want to have a free consultation for genomics-based fitness plan and know how it can help, chat with us at www.thesushamtkumar.com/pff. We will be back next week with another exciting episode. Till then, ciao.